Hello students, welcome to Sarasya classes. Today we are discussing crystal field theory. So, crystal field theory considers the ligand atoms as point charges, or we can say point dipoles, and does not consider any overlap between the ligand orbitals and metal ion orbitals. Now, had it considered a overlap between the ligand orbitals and metal ion orbitals, then this will be called ligand field theory and not crystal field theory. Okay. Now, so what are we proposing here? We are saying that there is a metal ion in a complex and it is surrounded by coordinating ligands or negative ends of a dipole. So because of this, a electric field is produced at the metal ion, okay, surrounded by some ligand ions or dipolar molecules. Now, such a electrostatic field will exert some effect on the metal ions. Okay, so this electrostatic approach towards the interaction between metal ions and ligands is actually called crystal field theory. Okay, now since we are discussing ions in a crystal lattice, so one can imagine that it is very similar to the effect of a chloride ion when we are considering the face-centered crystal lattice of a KCl. Okay. Now, what else does crystal field theory say? Crystal field theory examines the energetics of d orbitals in particular in given geometries. Okay. So basically means that placement of donor atoms at different stereochemical positions will perturb the d orbitals in different extent. Okay. Now it can be can have a metal atom like this, and the donor atoms can be coming from along one axis, something like that. Okay. So this is like a linear. Okay. This is like a linear, or you can have the donor atom, and they can come, ligands can come along the vertices of a triangle, like that. So this is trigonal planar. Okay, or it may be a case in which they might come along the vertices of a tetrahedron. Okay, in this manner. So like that, like that. Okay, in this case, they're coming along this direction. In that case, all right. Or one can say that they are coming along the vertices of a square. Okay, in this manner. Or we can say they are coming along the vertices of a trigonal bipyramid in this manner. That is how they are entering. Okay, or one can say they are coming along the vertices of a square pyramid, which is in that manner. Okay, so it is in that direction. So we are calling this as tetrahedral. Okay, calling this as square planar trigonal bipyramidal square pyramidal, and so on. Now, these may also come along the vertices of a octahedron in this manner. Okay, so these are the possible ways it may come, or one can also say that it may come along the vertices of a hexagon. That is in that manner. Okay, or it may also come along the vertices of a trigonal prism. Okay, so what I mean by that way, I mean something like this. Okay, so this can be the way to approach a metal center. Okay, I could have taken it a little bit higher, so we will keep that for another part of the lecture. So these are the possible arrangements in which we are calling this to be as the octahedron. We are calling this as to be plane hexagonal, and we are calling this as to be trigonal prismatic. Okay, so depending on the size of the metal ion, the ligands may approach the metal ion in the possible manners. Okay, and accordingly, the d orbitals will energetically arrange themselves in space. So over here, we are taking, for the simplicity of the discussion, we are taking the first one, which is the